Hello and welcome. This is a new episode from Arduino, and in this episode I'm showing to you how I made this ultrasonic controlled car using Arduino and Tinkercad. If you didn't hit subscribe, please subscribe to our channel to get the latest videos. In this video I'm showing to you this easy simple car I made only in 10 minutes using Tinkercad simulation software, using Arduino and the L293 motor driver and ultrasonic sensor HCSR04. This car can be used as the line following robot that follows beside a wall, that keeps distance to the wall, and using ultrasonic sensor to keep constant separation between it and a wall. Now let's see the hardware components. First, the microcontroller Arduino Uno connected to the HCSR04 ultrasonic sensor. Here the ultrasonic sensor is connected to Arduino. This is the power connected to Arduino 5 volts, and the ground connected to the Arduino ground, and the trigger connected to Arduino pin 10, and echo connected to Arduino pin 9. Now let's see the motors and the motor driver. Here the motor driver L293D H bridge IC connected to Arduino. Here we connected the enable 1 and 2 to VCC, and also enable 3 and 4 to Arduino VCC or 5 volts to be enabled all the time. And here we connected the logic power of the H bridge to the 5 volts, and here the power of the motors connected to a 9-volt battery. Make sure not to connect the 9-volt battery to Arduino directly, because it will damage the Arduino. But if you connect it to that round connector in the real circuit, this circuit has a regulator. That regulator regulates the voltage and gives it to the microcontroller as 5 volts, so it's safe to the Arduino microcontroller. Now let's return again to the H bridge IC. Here the input 1 is coming from Arduino pin number 6, and the output is connected on that pin to the motor. And here the input 3 coming from Arduino pin number 5, and the output number 3 connected to the right motor. Here the ground of the IC is connected to Arduino ground, and also there are internal grounds. Those pins connected together, actually they are connected together inside the IC, and the battery is connected to the IC, that pin, and also connected to the main ground of the circuit. Now let's see the code. Here we use the blocks on Tinkercad to generate the code only in 10 minutes. Here we want to maintain a constant distance to the wall, so we used an if statement, and then we put inside it a comparator to see if the distance is more than or equal to 10 inches, and then we used an input block to read the ultrasonic distance sensor connected to trigger pin number 10 and echo to number 9, and we used the inches as units. If that condition is true, then we set pin 5, that's the right motor, to 127. That means it works in its half speed PWM, and the pin number 6, that's the left motor, to 255, that's the full speed. That means that this car rotates to the right, because this motor is slower than this motor. The right motor is slower than the left motor, so it rotates to the right. Actually, those 3 pins were used for troubleshooting for LEDs that only were used to indicate the operation of the car. Here is another if condition. We used 2 if conditions. The first one, here we used the same read ultrasonic distance sensor on trigger pin 10 and the echo pin number 9, and we used units as inches, and then less than or equal to 10 inches, and then we used comparator and here another comparator to see if the ultrasonic sensor reads more than or equal to 7 inches. Then in this case we maintain the same speed on both motors as 255. That's the full speed for both motors. This is the range of the distance from 7 to 10 that we want to maintain. Then the last condition, we see if the read ultrasonic sensor is less than 7, then we make set pin, we put analog output on pin 5, that's the right motor, to 255. It works at its full speed, and the left motor to its half speed, 127. That means that the car rotates to the left because the distance is less than 7 inches. That's how we generated the code. Now let's see the code in text, we press the blocks plus text button to see that all the code is just generated. Now let's see the circuit simulation. We press start simulation and see how the circuit works. We see that the motors are running, so we see the distance from the ultrasonic sensor. Here the distance is more than 10 inches, so that motor is working at its half speed and that motor is working at its full speed, so that means that this car is rotating to the right. Then if we decrease the distance to 10 inches or less, here is the distance is less than 10 inches. That means that both motors are working at their full speed. It means that this car is moving in straight line. So now we make the distance less than 7 inches and we note that the left motor is working at its half speed and the right motor is working at its full speed. So that means that the car is rotating to the left, just as the line following robot, to maintain its distance from the wall, not more than 10 inches and not less than 7 inches. That was a simple project that acts just as a line following robot, but maintaining the distance from the wall using ultrasonic sensor HCSR04, and we've just generated the code in only 10 minutes. That was an easy project, so you can check it on our website aeroarduino.com. And if you like this video, please click like, share and subscribe. Thank you and goodbye.